everyone, and welcome to lesson 22.2 on page 297 in your Springboard books. Today we are going to focus on the first page, and then we will move on in more lessons to work beyond this. And a lot of this lesson is review, including using your unit circle to help you solve for the inverse and find your angle measure either in degree or radians. Now to start, we are talking about the equation 2 sine theta minus 1 and where it equals 0. So if we graph this, if we type this in, notice they're giving us the interval 0 to 360 degrees. So we want to double check once we type this into the calculator that our calculator is in the correct mode, in this case degrees. And then we also want to adjust our window. Since we're looking from 0 to 360, I recommend making that your x interval. And we could say maybe go up by 90 degrees. So we kind of see those 4 points and then x, y min, max min, just, see a little bit of a range there. And as we graph this, we see our lovely sine graph shifted down 1 unit, an amplitude of 2, right, of our parent function. Now, where this specifically equals 0, we see 2 points where it touches 0, right, the x-axis in this case. And if we trace to see what those values are, we see it equals 0 at 30 degrees and a little beyond 90 at 150, right? Those would be our 2 locations where theta equals 0. Now, this actually connects back to the last lesson because we talked about the identities, and one of them was sine of theta equals sine of 180 minus theta, aka your quadrant 1 sine value and your quadrant 2 sine value are the same. And we can kind of confirm this fact using sine of 30. And if we plug theta in to the identity, we can check out that these two are the same value. We kind of confirm that fact using that example there. Now, in previous activity 20 specifically, we talked about being able to solve this algebraically as well, where we add the 1 over, divide by 2, and we looked at our unit circle and said, okay, on the unit circle, where is my sine value, my y value, positive 1/2? Well, we saw that previously using this. Again, y value is 1/2 at 30 and 150, right? So we solved it algebraically, which in this case is probably even quicker than taking all that time to plug in and test this in our calculator. Now, we can, of course, do that again with sine theta, or excuse me, square root of 2 sine theta plus 1. You can graph this, but we can also solve this algebraically where we subtract 1, divide by the square root of 2. And after we rationalize, look at, okay, where does this equal negative square root of 2 over 2? Well, we know that happens when our y value is negative, so quadrants 3 and 4, down here at 225 and 315 if we're talking degrees again. So that would be our final answer for theta, 225 degrees and 315 degrees. Okay. Now, note for numbers 2 and 3, these are awfully small areas in your book to write, so either write really, really tiny or make sure that you are writing either on a separate notebook or in the My Notes section, just as an FYI. Try A and B on your own. Hopefully you got, for the source one, you should have rearranged so that you're looking where does tan theta equal square root of 3 over 3 positive only. That's occurring at 30 degrees and 210 degrees. The second one, you should have seen where does cosine of theta equal negative square root of 3 over 2. Well, cosine's negative in quadrants 2 and 3, specifically at our theta values of 150 and 210. And then this last one, what you would notice is if you try to find where sine theta equal 3, well, nowhere, right? There's nowhere on our unit circle where you're going to have a value bigger than 1 unit. And even if we try testing this out, sine inverse of 3, you get a domain error. So this one is actually no solution because there are no possible answers with an input value for your inverse that's that much. Now, a couple more examples, again, to kind of refresh your memory. This time we are changing to looking at, for part 3A, radians, right? We know it's radians because we're talking 0 to 2 pi. And as we start solving, if we add over the 1 and divide by 4, we get sine squared of x equals 1/4. And a reminder, when you square root, you're looking, where does sine of x equal positive or negative square root of 1/4? Okay, want that plus or minus. Now, a reminder, when you when you're looking for the square root, you can break up the fraction into being their own square roots in the numerator and the denominator. And you're looking for then, where is sine of x either positive or negative 1/2? Okay, so positive or negative 1/2 is occurring, again, from 0 to 2 pi at the values in the pi over 6 family, right, is where we're having positive or negative 1/2. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, we have officially 4 answers there for our x. Now, the next one, notice we are back to degrees. Okay, we have degrees here, 0 to 360. And this time we're looking for tangent. Now, notice here with this is going to actually require us to do some factoring. And again, think back to this just being 2x squared minus x minus 3 equals 0. If I asked you to factor this, you would look x method and say, okay, what multiplies to be a times c and adds to be b, negative 1? Well, that would be the values of negative 3 and positive 2. They multiply to be negative 6, but they add to be negative 1. So when we would rewrite this, since this has a value that is bigger than 1, we would have 2x squared minus 3x plus 2x minus 3, and we would factor this with grouping. So we would be able to take out an x, and we're left with 2x minus 3. Here we have nothing in common, so it's just a 1. 2x minus 3 is one of our factors, and then the x plus 1, the two pieces we pulled out, would be our other factor. Now, once we have this factored, now we can just put back in the tangent of theta anywhere we see an x. Okay, so we have 2 tangent of theta minus 3 equals 0, and tangent of theta plus 1 equals 0 when we set each of these two pieces equal to 0. So we're looking for, where does tangent of theta equal 3/2? Where does tangent of theta equal negative 1? Okay. Well, what you may notice here is that this first piece we do not actually have on the unit circle, right? Tangent being 3/2, that's not a value we actually know. So we're going to have to use the calculator to approximate that. Now, again, we're in degrees. So we're going to want to make sure our calculator is in degrees mode, which it still is from when we used it earlier. And we are going to take tan inverse of 3/2. And we get the value of 56.3 as our theta value. And we know that from 0 to 360, that tangent is positive 3/2 in not only quadrant 1, but also quadrant 3. So we would take 180 plus 56.3 to get the other quadrant 3 value, which is going to be 236.3. Now, tangent being negative 1 is going to happen in quadrants 2 and 4. And that actually is a value from our unit circle, but in case you forgot, we know that we have 45 degrees as the reference angle. And again, we want quadrants 2 and 4 where it's actually negative. So that's going to occur at 135 degrees. And then 360 minus 45 would be 315. So we have officially 4 answers here. 2 from the unit circle, 2 that we had to approximate. Okay, so these would be our 4 answers. Now, letter C is also going to require us to do a little bit of factoring. We saw an example like this in activity 20. We did a couple like this where we don't want to start by dividing that sine over. What we want to do is actually subtract the 2 sine x over and look at this as a GCF problem, right? They both have a sine x involved. So we're going to factor out that sine x. So now we have 1 sine x left here minus 2. And the reason we want to do that is because we have 2 different pieces we want to set equal to 0. Had we just divided that sine away, we would have lost sine of x equals 0. And then we also have sine of x minus 2 equals 0. Well, we talked about it before. Sine of x is never going to equal 2. Sine of x and cosine of x can't equal a number bigger than 1. So we would actually not have an answer using this one, okay? That's not going to happen. Sine of x equaling 0, though, is a value that we can find an answer for. Now, you need to be careful about your restrictions here. They want us to give answers from negative pi to pi, okay? So think about on the unit circle, where are all the places that our y value equals 0? Well, here and here. And if we're talking negative pi to positive pi, we're going to include negative pi. We're going to include 0, and then we're going to include pi, because again, notice the restrictions here are brackets. We're including on this interval all of those answers. Okay. So again, we're going all the way from negative pi, 0, and pi all get included because of how they are restricting us to give our answers. It's not just 0 to 360 here, right? Or 0 to pi for that matter. Last but not least, again, we are going to want to utilize a greatest common factor in this particular problem. We can factor out that cosine of theta, and we are left with 1. All right, when we divide that away, and then 2 sine of theta left in the second part of our expression. Okay, and again, be careful of your domain here. We're going to be looking for answers just from 0 to 180 degrees. Okay, now we could set each piece equal to 0. Where does cosine equal 0? And where does 1 minus 2 sine theta equal 0? Right? If we subtract and divide, we're looking where does sine equal 1/2? And what we're going to see here is that, again, cosine equals 0 in a couple different spots. Okay, cosine is 0 at 90 degrees, and cosine is 0 at 270 degrees. But again, going back to where they are restricting our domain on this one, they just want 0 to 180. So for cosine equaling 0 on this particular problem, because of this restriction, we're only going to put 90 degrees because 270 is outside of where we need it to be. And then for sine equaling 1/2, this restriction actually really doesn't bother us too much because sine is positive 1/2 at 30 and 150, which are both within our 0 to 180 limitation. Okay, so second piece would be 30 degrees and 150 degrees as your final answer. Now, we will work more with solving these in class, and we will also start talking tomorrow, okay, what if they're not all in terms of the same thing? How can we use our identities that we've been talking about to start solving and substituting in for these equations, okay? Thanks for watching, and we will work more with this in class.